All right, we are at 10 o'clock. Let's go ahead and get started here. So welcome everybody. My name is Bobby Henderson. I work here at Long Building Technologies in our hydronics and plumbing group. Welcome to another edition of Long's Coffee Break. But so without further ado, I want to introduce our guest today, Jeremy Zelmer with Industrial Steam. Today's topic is why do we deaerate, and we're also going to go through different types of deaeration techniques and products. Please stick around to the end for this week's fantastic prizes. Jeremy, please take over.
All right, thanks, Bobby. Again, as he said, I'm Jeremy Zelmer with Industrial Steam. We make deaerators. Basically, we make any equipment that goes around all boilers in the boiler room. So yeah, and so basically today we're going to go through and discuss why we deaerate. So we are protecting the boiler condensate system. We're going to remove the oxygen, carbon dioxide, provide preheat, serve the boiler. So we're going to save energy by increasing efficiency, reclaim flash loss to prevent corrosion. So with taking the oxygen out of the water, we're reducing the corrosion that can happen in the boiler tubes. If you do nothing to remove the oxygen, the iron in the system will disintegrate the metal, forming rust. If makeup water is untreated, 16 gallons of makeup water can dissolve up to 50 pounds of iron in 1 week of operation. So as you can see, we're mechanically deaerating the water so that also too you can reduce the amount of chemical being used. As far as oxygen scavenger. The oxygen scavenger can just be used to, take away the trace amounts of oxygen that we're not removing. So that's the primary function of the deaerator, is to remove the oxygen, so that the boiler runs more efficiently, reduces scale, longer lifestyle span. Here's kind of the layout of what we would look at as far as, where the deaerator would be in the system, as far as conditioning. As you can see, you got the deaerator, the blow down, the fire tube boilers. We're feeding water in from either a heat recovery unit or just water softeners into the DA. So that's just a general layout of how the system would work. The most basic type of deaerator out there is a spray type deaerator. In this illustration here, this kind of gives an idea of how it works with the different colors with steam, water, and air, and how it deaerates the water and goes out of the tank. As you can, it's of course the most expensive deaerator. There are 2 stages. This deaerator is very dependent on steady state conditions, meaning that it does not like to see a lot of temperature fluctuations coming in. No gravity returns, no trap returns, easy to package. The one reason why we say that this is really dependent on steady state returns is that we need consistent steam pressure always coming into it from the steam pressure reducing valve. Because as you can see, when we get down in here, we're spraying makeup water in, comes down around the steam pipe, the steam comes down here. Well, then we got a plate down here that actually the water and steam meet. And where they meet, then we start driving mechanically the oxygen out of the water that can come around, and then it goes out this vent in your non-condensable gases. This is why it is very critical, and you will see on every deaerator that you'll see that it has a steam plume going out. Typically, you'll see a 4 to 5 foot plume. It may look like in the dead of winter that it's a ton of steam. And in actuality, we have a pre-drilled orifice in there. So equivalently, you're losing, approximately 1/2 of 1% of the steam usage per hour is what's going out. We're basically just letting enough steam out to know that we're getting our non-condensables out of the deaerator. All the oxygen and carbon dioxide that we're driving off, we have to have a means of getting that out of the tank. So that's what you're seeing, and that's the means of why we have a vent on these units. Without having that vent, you would get into a situation where you couldn't build up temperature, and you would actually get to the point where if you're not venting enough, the oxygen will start taking the steam space away and not allowing as much steam in the unit because it's competing for the same space. Here's kind of a general layout of what the deaerator looks like. As we said, needs steady state conditions. And so we recommend using it in a 70 to 100% makeup water condition. Tray type deaerators, probably one of the most oldest and most common types out there. Just the same concept we're showing here with the steam, water, and air. Water sprays into the top. The advantage with the tray is that steam comes in and is then routed. There's a steam deflecting plate here. The steam is then routed up so that it counterflows to how the water's coming down through. However, the difference here is trap returns or any flash returns that we have coming back, we can also utilize that flash in the deaeration process, whereas we can't with the jet spray deaerator. So this deaerator gives you a little bit more leniency as far as it comes with, more conditions being not steady state necessarily. We still do want to a degree somewhat steady state, but at least we have a little more flexibility with this type of deaerator. Here's kind of what the general deaerator is going to look like. What the biggest difference that we got a dome up here to house those trays. So obviously it's a higher first cost than what your jet spray is going to be. However, we can take a little bit more variance, as I said, 50% makeup water, higher high temp returns. We can utilize that flash, excellent turn down, variable loads. And like I said, it's probably one of the most common deaerators out there with the most history. When should a surge tank be used? When we say that, we get above conditions with either the jet spray or the tray, and you're getting into 70%, like 30% above on the of 70% condensate return coming back, or 50% return coming back, then we want to start looking at installing a surge tank in front of these deaerators, especially the spray type. What we want to see is that we're blending our makeup and our condensate together so that we're sending a consistent blended temperature over to the deaerators, this way to allow them to work at the maximum capacity that they're designed for, and gives them the best mode of operation. So that's where you'll see where we start putting a surge tank in place. The surge tank provides blended feed water to the boiler, evens out the makeup, the flow, and collects the pump condensate, mixes it in, and collects gravity returns. So everything and anything comes in, and then we size our makeup inlet on our deaerator, the modulating valve for 100% makeup, so that all of this goes through that for its entire load. Unique to industrial steam, we make what we call our 2-compartment pressurized recycling deaerator. With our recycling deaerator, we have a recycle pump that runs all the time. And basically we have a surge section and deaerating section. However, they are both common to each other. So unlike a duo tank or anything like that, it's not a double internal head. We don't get corrosion.
Jeremy, excuse me. We're having a little trouble with your microphone. I think you might need to recenter yourself there. There you go. Thank you.
You bet. No problem. So unlike this is a true split tank. So as we spray in, we have a recycle pump that consistently runs all the time and sprays into here. So this is our first stage of deaeration as we spray the water in. Then as we spray it in over here, we're getting a second stage, and then it drops down in our deaerated water. However, we have an internal baffle in here that will control the water level on the deaerating side. And as it gets to that baffle level, it will spill back over, and then we start the whole process over again. So one thing that makes it nice with these units is that we are always consistently recycling the water, whether you have 100% makeup, 100% condensate return, 100% load going out, 100% load not going out. As long as there's steam on this unit, it will always maintain the temperature needed. As I said, high temp returns, 100% turn down, all condition testing, history. We've been making this deaerator for over 50 years. I have a lot of deaerators out there, steam flows that probably get replaced after 30 years, and most of the time they're getting replaced not because the vessel's rotting out, just mainly because they're 30 years old. Also, as a factory warranty, Industrial Steam does a 10-year prorated warranty against corrosion on the vessel, which is one thing that we as to why we think this is such a great deaerator. A consistent advantage of a consistent recycler will provide double O through all loads, guaranteed performance, 10-year warranty vessel. Start boiler with heated deaerated water, meaning that you don't have to have water flowing out of the deaerator. And as long as the recycle pump's on and you get steam to it, we can start heating the water up without having to move cold water out and put new cold water in to get our temperature up. We'll provide guaranteed performance with pumped returns at any percentage. No surge tank required because we have it built into the tank. So it cuts down on your footprint if you have a surge tank and a pressurized deaerator together. Costs less to install than 2 tank systems. Will accept trap returns, stable operation, so fewer pump problems. Here's kind of the overview of what it looks like in our recycling system compared to our 2 tank system. One thing too that I'll point out is that with the recycling deaerator, we have one level control feeding the water in, where on the deaerator and surge tank, you have surge tank makeup water coming in, so you have level control on both tanks. With this tank, we have one, so it's an easier operation of the tank as well. That's the short synopsis that I have today for this. I'm going to hand this back over to Bobby and let him give out some prizes.
Jeremy, thank you very much. Really appreciate it. If anybody would like to learn more about Industrial Steam's product, where should they go?
They can either come to our website, industrialsteam.com. They can go to Long. Long, has great knowledge of our equipment as well. There's also, we're members of ABMA, American Boiler Manufacturers Association. I did a podcast on one of those, so that's available. Bobby has the link for all of that. But yeah, just in general, we're here to answer any questions.
Yeah, we'll make sure to send out that podcast episode. Thank you very much, Jeremy, for your time. So thank you all very much for joining this week's coffee break. Please join us next week when we will be discussing a simpler way to design your VRV system. Thank you all very much. Have a great rest of your day. Take care.